Hello. So today I'm going to talk about new operators that have been introduced in SQL for data warehousing. So I'm going to discuss 4 or 5 operators that have been introduced, and these operators have made the life of users of data warehouse easy, right? And like this, there have been a lot of other operators and features that are getting added to relational databases and SQL from time to time, right? So you need to keep track of all of them, and based on your specific needs, you can select a database, a relational database, which has all the features that you are looking for. So it depends on what kind of features you are looking for, and accordingly you can choose a relational database. So let me begin. And so examples used in the presentation are taken from Raghu Ramakrishna's book on database systems. So let me begin with the set of operators that I'm going to talk about today. So first is the rollup, right? Second is the cube. Third is Windows queries. Then the fourth is top-end queries. So these are the 4 important uh, operators that have been introduced in SQL over a period of time. And let me give you some idea about each one of them. So rollup, you understand that it is so while discussing OLAP in module number 6, you must have come across this operator or this operation, OLAP operation called as rollup. So rollup basically allows you to aggregate data along a hierarchy, right? So that is what is rollup. So what kind of support SQL provides in terms of rollup. Then there is cube. So you also saw the cube operator in OLAP, right? So corresponding cube operator has been introduced in SQL to facilitate that process. And in module 6 you also looked at how to compute cubes efficiently, right? Then we have window queries. So these are like so you can frame a window across any tuple in a relational table, and this helps you in giving like moving averages and other such queries. And then you have top-end queries. So top-end queries are basically used for, say, for example, finding out the top 5 selling products, or finding out the least 10 selling products in your company, right? So how to do that efficiently, right? So not in the brute force manner. So we'll look at all this. And the first two, like rollup and cube, are very closely linked to the group by, right? So because these both are talking about aggregation, so group by operator in SQL, it is very closely linked to that. So let us look at these queries one by one, these features, operators one by one. So first let me excuse me. So typically a single OLAP operation can lead to several closely related SQL queries with aggregation and grouping. Okay, so cross tabulation is an example. So cross tabulation, you understand that it looks like this. So there are some values A, B, C here, and you have values X and Y here. So you do the cross tabulation, so 10, 20, 30, so this makes it 60. So 15, 25, 25, that makes it 65 here. And then what is that, 10, 20, 30, right? So this makes it 55, this makes it 45, and this makes it 25 here. So this makes it 125, right, which is the sum of these two. Yeah, so this is what is typically called as cross tabulation. So how can you generate a cross tab using SQL? Okay, so that is what is the idea. So typically we use what are called as report writers on top of SQL to generate these cross tabs, and even with report writers it is not easy to get this kind of a cross tabulation. So let us see. So the cube operator first. So so this is my sales fact table. So this is a sales fact table here, right? So this is a sales fact table here. So it is product ID, time ID, and location ID, and there is a sale volume or a sale amount, right? And then you have a location ID. So I'm giving you a schema. So location ID, there are 3 cities in 3 different states and in 2 different countries. Then product ID, so there are 3 products that I'm talking about, and 3 dates that I'm talking about, 10th, 11th, and 12th of November, right? Okay. So cube operator. So first of all, let me look at this particular query. So if you look at this query, so what I'm doing is I'm trying to select year and state and totaling on sales, right? And I'm grouping by year and state. Okay, and I need a join of 3 tables, which is sales, time, and location. Okay, because sale information is there in the sales table, time, year information is there in time, and state information is there in locations. So when I do this, I get say, if you see, so it is year wise and state wise. So year wise is here information and state wise is here. So I'll get this part of the cross tab. Okay, so this is a normal group by query that I have written to generate this part of the cross tab. Now, so how many such queries would be required to build the cross tab? So that is what we need to look at. So now I do this. So select t.year, sum.sales. So I'm now doing a year wise grouping. So year wise grouping, so that means this portion of the cross tab is now generated. Okay, and now I do this. So let me use a different color. So okay, right. So now I'm doing a state wise grouping, group by l.state. Here grouping by t.year, and here it is year and state. Okay, so now this generates this part of the cross tab. So now there is one more value, which is 399, which needs to be computed. So this, you can see, can be computed in 2 different ways. One is that I add up these values, or I add up these 2 values. So both would give me 399, right? So now let us see how I can write this 399. So select sum sales. Okay, sales.locality. So I just do this query, or I do this query, right? So both these would give me 399. Okay, so this is basically a cross tab. So how many queries, how many group by, how many such queries I needed? So 1, 2, 3, and one of these 2, that is 4. So 4. Okay, and there are 2 dimensions that are involved in this. So I can say that I need 2 to part 2 is equal to 4 queries to generate this information in the cross tab. I'm not talking about formatting related issues, right? So formatting would typically be done by the report writers. So using SQL, you can only generate the data that is required for the cross tab. So if you look at this, so this is what is a cross tab generated using 4 different SQL queries. So let me clear the annotation. Now cross tab can be thought of as a roll up on the entire data set on location, on time, and on both location and time dimensions together. So each roll up corresponds to a single query with grouping, and given a fact that you have k associated dimensions, we will have a total of 2 per k such queries. So now let us look at the group by construct is extended to provide a better support for roll-up and cross-tabulation queries, and collection of group by statements is equivalent to group by with cube keyword with one group by statement for each of the k subset, each subset of the k dimensions. So now let me introduce this cube operator. So I am doing now select t.year l.state sum. So you can see it is a two-dimensional crosstab that I am trying to generate. From this condition also remains the same as we had in the earlier queries, which basically generated the body of the crosstab. Everything is same. Only thing is that instead of group by, right? So earlier it was group by, and now it has been replaced by cube. That's the only change I have done in that query. So now group by, or you can say cube, right? So not, it is not replaced. So it is group by cube. So this is a new keyword that I am associating with this. So earlier it was simply group by t.year comma l.state. So now let us see what this generates. So this would generate this crosstab for you, not in the format that you're seeing, but all the data elements that are there are generated using this cube operator, right? And you can see in the relational, because this is an SQL query and it will generate a relation, so this is how it would look like. So you can see all the values that are there, 1, 2, 3, 6, 9, 12 values are there in this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values have been generated using a single SQL query. Okay. Now we introduce another operator which is called as the roll up. So instead of cube, I am using what is called as, so cube has now been replaced by roll up. So you can see the result of this query is here. So now what is the difference between this query, the cube and roll up, so that you will be able to understand in this query. So if you look at t.year, which appears on the as the first operand in the roll up, right? So everything is there except that all things that are there in this. So if you go to the previous slide, so there were two more. So these two are actually not featuring in the roll up. Okay, so if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so two things are not featuring in this. Similarly, if I reverse the role of year and state in this roll up, you should be able to see what the roll up would be, what would be the result. So then in that case there will be only one all in l.state, and here there will be more alls than here, right? So you can see, so now I am trying to tell you about the difference between the roll up and cube. So roll up and cube are different. So cube generates all possible aggregates, and in roll ups you can be selective about what aggregates you want in this. So that's the only difference that you have between the roll up and the cube. So roll up you can be selective, whereas cube by default would generate all the aggregations possible that are there. So now let me come to window queries. So as you know, okay, sorry, window queries, this in should not be there, sorry. So window queries. So time dimension is very important in decision support. So just update this so that so window queries. So you have you know that time dimension is very important in decision support, and queries involving trend analysis have been difficult to express in SQL. So this is a well-known anything that you want to do with time is not very well supported in SQL. So a fundamental extension called a query window is introduced. So let us try to understand what is this query window or window queries. So window clause in SQL allows us to write such queries with trend queries over a table viewed as a sequence and which is implicitly based on user specified sort keys. So let us see how this is done, and it is also referred as querying sequences. Sequences means which have a time, so it's a time sequence basically. So window clause intuitively identifies an ordered window of rows around each tuple in a table. So around each tuple I can form a window. So suppose I have rows corresponding to sales in year 2005, 2006, 2007, 2008. So suppose I have this 2005, 2006, 2007, 2008 and so on. So what I can do is I can frame a window around say 2006 and I say that it involves these three. I can frame a window around 2007 and say it is like this. So I can get what is called as a 3-year moving average. So with 2006 being at the center, I can go one here and one here, right? One before that and one after that, or two before that, two after that, or it need not be symmetric also. So you can go 1 year back in time and 2 years ahead in time, right? So from the, and not ahead in time, but from the point of reference. So here it is 2006. So we can explain, we can apply a rich collection of aggregate functions to the window of a row and extend the row with the results. So let us see how we can do this. So for example, we can associate the average sales over the past 3 days with every sales tuple at a daily granularity, right? So let us see how we can do this. So this gives us a 3-day moving average of sales. So basically concept of moving averages is introduced. So like the window operator, group by allows us to create partitions of rows and apply aggregate functions such as sum to rows in the partition. So group by also allows you to do that. So if I do group by state, so I can collect all the records for a particular state and then do an aggregation of that. Then I do it for the other state and so on, right? So it is similar to window is similar to group by. So unlike window, there is a single output row for each partition. So that's the partition, rather than one output row for each row, and each partition is an unordered collection of rows. So in case of group by, what happens is that you create partitions which are say based on states, say state 1, state 2, and there will be one value for each partition. Whereas in window, what happens is that for every row, say if I have this row as 2006, this is 2007, 2008, so I'm also making say 2005, right? So I'm making a partition which is say 2005, 2006, 2007, right? So I'll go get an output for 2006 which is a 3-year moving average for 2006, right? Similarly, I will also get a 3-year moving average for 2007 and so on. So every row in the window has a value, right, which is an aggregated value in some sense, right, typically an average. So that is the basic difference between group by and window. So now in the next few slides, so what you can do is you can try to compare this with the cube. So you know the cube operator, right? And I'm also now introducing this window operator. So it is a good idea to compare window. I have done the comparison between group by and window, and cube is nothing but a collection of group bys. So it should come naturally to you. So try to compare this window with with the cube operator. So try this on your own. Okay. So now let me give you an example. So let me clear this. Okay. So select. So you look at this query. So it should not appear difficult to you at all. So you can see now there are no group bys, only a window. So select L.state T.month, average sales, right, over W. W is defined here. So first let me change the color of the pen. Yeah. So you can see over W as moving average. So I'm trying to find the moving average. So this whole thing, average S dot sales over W, in the result it will be represented as moving average. So moving average would be one of the columns. From sales, so this is the normal join and this is the join condition. Now I'm defining the window. So window W as partition by L state. So I'm doing it with respect to state, order by T month, range between interval 1 month preceding and 1 month following. So you can see what I'm doing. Around every row in the partition that I'm creating, I am going one up and one down from the current position. So if this is my current position, so I'm including one row above it and one row below it with respect to the values in a particular column, and getting what is called as a moving average. So from and where clause proceed as usual to generate an intermediate table temp, and windows are created over temp. So you can see that if I do this, so when I do the join and other things, so I'll get a temp relation. So from and where, right? So 3 steps in defining a window. So define partitions of the table. Partitions are similar to groups created by group by. Specify the ordering of rows within a partition, right? Order by, so that is the ordering, and then frame the window. So instead of 1, I could have put a 2 here and a 2 here, or if I want it to be asymmetric, in some case I can put 1 and 2, or can we have 0 and 1 or 0 and 2. So all these things you have to try and figure out. So frame window, establish the boundaries of the window associated with each row in terms of ordering of rows within that partitions. So this is what is done, and so define partitions. So this we have done. So up to 3, I've just repeated these 3 points. So here, so window for each row includes the row itself plus all the rows whose month values match month values are within a month before or after. So this is the meaning of 1 and 1 here. And a row whose month value is June 2006 has a window containing rows with month May, June and July 2006. That's how I frame a window across this. And some more details about this. So answer rows to each row is constructed by first identifying its window. Then for each answer column defined using a window aggregate function, we compute the aggregate using the rows in the window, and each row of temp is a row of sales tagged with extra details about time and location dimensions. So one partition for each state, and every row of temp belongs to exactly one partition. So this is some details about this window operator. So main idea is that you can construct a window around each tuple in a table, and you can get an aggregate value for each tuple in the relation. So that is what is the window operator in a nutshell, right? So once you work with this operator, right, so you'll understand it better. But the main idea is this, and I have already contrasted it with the group by. Okay. So now let me come to the last topic for this lecture, and that is the top n queries. So if you want to find the top 10 or so cheapest cars, it would be nice if the database could avoid computing costs of all cars before sorting and determining the 10 cheapest. So the idea is on which this top n queries are based is that guess a cost C such that the 10 cheapest then the 10 cheapest cars, all of them cost less than C, and that not too many cars too many more cost less. So what I am saying is, I am saying, say if I am talking about cars, so if I put this C is equal to say 2 lakhs, right? So I am saying that I should be able to find 10 cars, at least 10 cars which cost less than 2 lakhs, right? So this value I would try to determine from my knowledge of the automobile industry and how cars are priced. But if I put the C to be say 5 lakhs, right? So suppose I here get 11 cars, and if I put 5 lakhs I get 40 cars, right? So again I'll have to sort these 40 to get the 10 cheapest. So if the guess is right, great, and we avoid computation for cars that cost more than C. So I've avoided all cars which cost more than C. If the guess is wrong, so then we need to reset the selection and recompute the original query. So it is basically a kind of a hit and trial method to work out a good value for C. If C is too less, you will not get enough cars. If C is too high, you will get much more cars than you would want, right? So this is how it is done. And so what we do is, so this is how you specify the top n queries in SQL. So select p.id, p.name, p.sales, s.sales from this join, order by sales decreasing, and then I have this one extra record here, one extra information that is optimized for 10 rows. So if I remove this from my SQL query, so this thing is nothing but the brute force method, which we should try to avoid at all costs. So here I am doing sales in descending order, right? And I am picking up the top 5 or top 10 queries, right? Or the top 10 results, right? But what this optimize for 10 rows does is that it avoids the brute force method, right? So it is much more efficient. So optimize for construct is not in 92 version of SQL, but it is, and not even in 99, but in later versions of SQL, right? So this optimize for is there, and it is supported by IBM's DB2 and Oracle 9i. They both support this, and compute the sales for only those products that are likely to be in the top 10, right? And this is again, now I'm giving you some more information. So cutoff value C is chosen by optimizer using the histogram on sales column of the sales relation. So this, so you know that in the metadata part, so we maintain the histograms of some values in the tables, right? And the only problem with these values is that these values are not updated with every change in the sales table. So they are kind of out of sync with the current tables. So metadata is not updated with every update in the tables. So this value that you might get from the histogram, right, would be a little bit outdated. But as I told you, it is a hit and trial method, and any value that the histogram suggests would give you a decent cutoff, and it leads to a very efficient approach. So how to choose C? And so this, I told you, it's a problem. What if you get more than 10 products? What if you get less than 10 products? So if you get more than 10 products, you have to sort them and find out the top 10. If you get less than 10 products, then you have to basically lower the value of C to get more products into the result set. So with this, I wind up this lecture. So basically we introduced 4 operators. So one is roll up and group by, and then third is window, and all of them have kind of connection with the roll up with the group by, and roll up and cube are nothing but collection of group by operators. Window is slightly different than group by because the kind of output it gives, and in group by, as I said, there is one output for a partition or for a window, right? Whereas in window you can have an output for each row of the table. So that is the primary difference. And as I said, it would be a good idea to compare the window with the cube, right? And then we looked at top n queries. So there are constructs that optimize this, optimize with respect to the brute force method, and we make use of the metadata that is present, and which gives us some idea about how to choose the value for C, that is the cutoff. So I'll not be talking about products that did not sell, right, more than C or less than C. So anything that is say if I'm talking about the cars, so if they cost more than C, I'm not going to consider them, right? So, and you may need to do a couple of trials before you can actually get a decent value of C, where you get the desired number of cars that you are looking for within the price range. So with this I wind up this module number 9. Now module number 10 is on real-time data warehousing. So that is the next topic that I'm going to cover, and it will mainly talk about some applications of real-time data warehousing and strategies for providing a real-time data warehousing. So how you can make a data warehouse real-time, and here the role of operational data store will also be highlighted. So the next lecture will be on real-time data warehousing. Thank you.